Hello, everyone. Our weekend is starting, but our analytics is not going to stop. We are not going to take a break, and we are going to discuss something very interesting and very important from the SQL scripting perspective. And that is the analytical function, which comes with every database software, and that provides you some true power to write some great analytical queries that you can use, to produce these summaries, ranking information, aggregation, based on the chunks of the data within a single table, right? So we're gonna see them in details now. Our journey is going to span on multiple videos because we cannot cover all these function within a single video. So obviously we're going to spend a couple of videos to learn the Windows function. And after learning these analytical functions, you're going to have a very good grip on writing some advanced SQL queries, because you have already learned the joins in inner queries, and the aggregation we have already covered. So with these analytical queries, we're gonna have a very good command on writing some advanced analytical query. So let's first discuss the Windows function, what they are. Let me quickly share my screen, and then we'll see them in action. All right, so you can see the importance of the Windows function that Microsoft literally publish a separate book on this topic. Like, you can go and you can purchase or get a copy of this book. Great book from the Windows function perspective. There are a couple of other prints in the market that provide the Windows information about Windows function within the SQL language. But obviously, if you look the books from the Microsoft Press, you're gonna find they discuss the topic in a very deep and detailed manner. So you will get all the answer regarding that topic, right? So that's why obviously I would recommend this book over other prints, and I'm consulting the book as well for my on practices. So obviously I'm actually sharing you from the experience, and in the upcoming video we're going to cover some of the contents from this book, which will give you a very good understanding how you can write the Windows analytical queries for your own work items. All right, so that's a brief introduction. So Windows function, we normally divide them into four categories. One of them is the ranking function, and then we have the Windows aggregates, accumulating aggregates, and then we have the analytical function. Most of these functions, why we call them the Windows function, normally once we apply the group by clause in our select statement, it applies the whole table, right? So we don't have the opportunity. We can chunk the table into small chunk and then apply the aggregation. Obviously we specify the column, and then the query chunk the segment, or chunk the table parts based on the combination of those column value, and then apply the aggregation function, right? But how about if we want to first chunk the function, chunk the table, and then we need to apply the aggregation, right, over there. So these small chunks or these small frames are called windows. And if we want to apply any particular aggregation, we can do it through the Windows function. And obviously they don't need the row to be accumulated, because we can apply the function only on that frame or window, and then we can plug it with the rest of the data set without grouping them, or without mentioning them in the aggregation. So which is a very powerful feature, and we're going to see a couple of practical use cases which are highly relevant in our day-to-day activities, where we these Windows function really help us a lot. So our discussion is going to start with the ranking function. So we're going to see today in this video, we're going to discuss the ranking function, and we have 4 ranking function. One of them is the row number. Row number is, like you can see, it allocate a unique value to each of the row number, or you can say it allocate an index number to each row based on the over clause, because all these ranking function, they are followed by the over clause. And then over clause, we mention the column by which we want to arrange the sequence. So for example, if I have, for example, my employee table, and in that table I want to sort it by the DASIC, and then what I'm going to do, I'm going to actually allocate the index based on the DASIC, right? So you know that we only have normally one auto number in the table that we can define, but with the roll number we can allocate these index based on any column sequence that we want, depending upon the business requirement. Now the rank is so that index is also the you can call it rank. The difference between rank and row number uniformly apply on each row regardless of the repetition of the value. So for example, if the title of the person is going to be repeated, because for example, if we have the production department, in that production we might have more than one production engineer, right? So what rank does, it allocate the same value, because you can see the title is same, so it's going to allocate the same value to each title. And once the new title comes in, whatever number it has been allocated to the previous value, it's going to actually calculate, and then it's going to skip those numbers from the sequence and start from the next number. So for example, when it reached to the production engineer, it reached, for example, the number was 14, and then it has seen that we have 3 production engineers. So what rank is going to do, it's going to allocate 14 to 3 title, same value, because it's a rank, it's a ranking on the same level. But when the next title comes in, for example, production supervisor, right? So it's going to actually, instead of allocating 15, it's going to allocate 17, because it's already allocated three number in there. However, if we want to actually allocate 15, we don't want to skip any sequence, we use the dense rank, because dense rank won't consider the multiple values in the sequence. What it does, it actually allocate whatever the next number in the queue. It starts the new title with the new number. And obviously, last but not the least, in the ranking function is the end tile. End tile, like you can see, it more like create the tiles or create the blocks based on the number of number we have mentioned. That's why it's called end tile, because we pass the parameter. So for example, if I want to divide my block into 4 chunks, right? I want to actually group the data by 4 chunks, right? So what it's going to do, it's going to actually divide the row into 4 blocks, and each block is going to have an index number, which is going to be associated in a sequence, right? So that's how we actually divide our table into tiles, right? And these things are very relevant once we build the analytical queries, and once we look some advanced reporting that we want to produce from our data. So these things really become handy for us to address those kind of problem. Now that's all about the theory. And now we're going to jump straight into the dev environment, because we're going to apply all these functions, and whatever we have discussed so far, we're going to see them in action. Let me stop my screen and let me go back into dev environment. All right, guys, we are in our dev environment, and the database and the table is quite familiar. If you remember, we are using the employee table, we're going to do the same thing in the Spark SQL. So the same analytical function that I mentioned, they are available within the SQL Server. We have a similar function available in the Spark SQL. So you're going to see the uniform functionality between two different, areas of dealing with the data. Excuse me. All right, let me first show you the table structure. Let me run it. We have the employee table, and this schema is quite familiar with you. If you are not familiar with the table or data model, please watch the video where I have discussed the data modeling of the example set that we have used a lot in these videos. All right, so what I'm going to do, obviously you can see we have the job title, and I want to keep things simple. What I'm going to do, I'm going to actually, I already have a key that has been based on my business entity ID, but I want to allocate a unique index to my rows based on the job title, right? And obviously I cannot touch my business entity ID because it might have a relationship with other tables in the normal form, because this database model we are using from the OLTP. So I would prefer not to touch the existing indexing. I will create the new indexing, and that's where the Windows functions are going to be very useful for me to achieve that thing. All right. So rest of the column, like I mentioned, they're one of the biggest difference with by the group by clause or the analytical function. The main difference between that with the group by, if you use any aggregation function, all other columns, they have to be part of the group by clause if you want to use them in the output. What with the Windows function, the restriction is not there. Like you can apply the Windows function and all other columns can appear without any without any aggregation or without mentioning them in the group by clause. So which is very powerful in terms of most of the time we have to apply the aggregation on some part of the table, and the rest of the outcome we just want to display as it is, which is not possible in the group by aggregation, because every column or every information piece that is going to be used in the aggregation query, if you remember, it is either going to be part of the aggregation function, or if it is not part of the aggregation function, then it's going to be part of the group by clause. So right, so that's the biggest difference between aggregation function used by a group by or aggregation function used by the Windows function or Windows clause. Sorry, Windows function, not Windows clause. We don't have the Windows clause. So that's one of the major difference, right? And we're gonna see now. Like I mentioned, we are going to now assign an index. So that's why we are using row number. And like I mentioned, then after that, we mentioned the over clause, and over clause actually take the column name and it's sorted by that column. And then based on that, it allocates the index to the record. So you're gonna see we are mentioning order by clause, and even we have even further advanced functionality where we partition the data by the columns within the over clause. But these are more like the next step which we're going to do. Right now we are just thinking, okay, we have the row number, we are going to associate a unique value to my record, and then these unique values are going to be allocate or associate by organization level in the ascending order, right? So you can imagine now what it's going to do, it's going to obviously sort or arrange the organizational level from low to high, and in terms of alphabetical order, right? It's not like the hierarchy, because we are just dealing with the textual data. And then based on that sorting, it's going to associate the index number to each record. All right, so let me just run it now. So the last number is the one which we have just allocated, and we see. So like I mentioned, you can see we have already seen that the job title has been, sorry, we have used organizational level, right? So organizational level has already been sorted, and you can see null is always coming on the top, because with null, we don't know what kind of value it is. So that's why it is treated as the lowest value, and that's why it's coming on the top level. Sorry, we are using the organizational level. What I can do, let me just use the key. job title. I think that would be much easier and relevant to the explanation we have discussed, right? So let's do by job title. So now you can see the accountants are coming up, and that's why I think when I prepared this demo, I didn't use the job title, because that is not showing us the hierarchy of the organization. You know, normally in the organizational structure, we have the CEO on the top, and then we have the further layer, which normally have either the executive members who are reporting to CEO, and then the directors, and then the flow goes down, right? So let's use the organizational level. I think that will be much logical. Yeah, because in that way, you can see your hierarchy has been arranged. You can see we have the chief executive officer, and then we have the vice president. And then obviously in the same level, you can see we have all these, high title. And these are all the example. You can obviously arrange it by your own organizational structure. But the most important thing, you can see the organizational level has been arranged. We have from top all the way to the bottom. So you can see more we go down, we're gonna see the lower stuff, or I would say the labor stuff at the fourth level, because don't be confused with the sorting order, because normally level one is the top level in the organizational hierarchy, right? And now if we come to our first analytical Windows function, we use the row number. You can see each row has been allocated a unique index, right? And that indexing is not by the key, because you can see we have business entity 1 to 16, 25 to 34. These are the IDs which are associated with the row, right? But this is more like the artificial IDs which we have generated based on the requirement we got from the business, and that is linked with the organizational level, right? Now we can use it to produce any kind of report or any any further transformation if we want to do it, because now we have an indexing based on the job title. So you can see now Windows functions are in action, and they are helping you to produce some really nice and complex result, right? And you can see the sequence is same. It's the auto sequence, like it's not going to be repeat the same value at any level, right? So it's a very straight row number combination that we are producing based on the column sequence that we have mentioned in the over clause. All right, our first query is done. Now let me copy, and I'm going to show you the similar thing, but from the rank perspective. All right, so now you can see we have ordered by the organizational level, and we have these four records are sitting, sorry, not four, I think they are more, like they are six. These six records, they are sitting in the level one, right? So you can see the rank number has been, sorry, let me just. So the rank number has been repeated all the way till we have the new organizational level. But once it reached to the new organizational level, instead of using the next rank number, which theoretically be 3, it is using number 8, because it's going to skip all the ranks which has been in the sequence but has not been used, just because we are within the same window of or same frame of the organizational level. So now you can see why we called it window function, because it is operating within a particular window of the table, right? It is not working on the full table level or on a group of records level. It specify a particular window. So that internal clause over clause, it is defining a window, and then the ranking function is applying its functionality on that particular window. So in this case, you can see that's the window where it is applying the ranking. All right. So the next number is 8, but we are not happy. We want to use the next rank number because maybe business is not going to understand why we suddenly shift our jump from 2 to 8. So in that case, what we are going to do, I'm going to create another column in the same query because I want to show you the show the functionality side by side. So now you can see the window is same. Like we can see the number one is the frame is the same, window is the same. But once it finished that frame, applying the ranking function, the difference is allocating the next value from the rank. So once we use the dense rank, instead of jumping the rank, it is allocating the next rank in the queue. It's not going to skip all those values which has been missed just because the windows of the window of the data is repeating. Wherever it's going to find the new organizational level, it's going to start with the next value of the rank, which is obviously in the sequence is 3, right? And then it goes on all the way till you can see in the lower values. All right. So that's the dense rank. And now last but not the least, which I'm going to show in here, and tiles, right? And I'm going to divide my data into 5 tiles, right? So for example, I'm just going to additional tiles, right? So let's see what's going to happen. Now it's going to divide my data into 5 tiles, right? And how it will do, I'll show you the formula. Let me first run it to show you. So you can see we have all the way organizational tiles. Our first tile is finishing at 160. Keep sorry, what's the what happened to my, sorry, I need to add the row number so I can show you. I think there was. All right. Yeah, I think that's we can see. Now, where the tile is finishing, that's the most important point to understand. Let me see where it is finishing. So you can see the tile is finishing at 58, right? And then we can see, because we have divided our full table into 5 tiles, so obviously our tile number is going to be end up at 5, right? Now let me show you the formula how the system has calculated the tile. So you can see all how many records we have. We have 290 records. So if I divide 290 by 5, it's going to be 58. So every 58th record is going to allocate a new tile. And that's why I told you that keep that point in mind where the tile is changing. So if I go up and I just scroll down, at the 58th record, the first tile is finishing. And at the 59th record, the new tile is starting. So that's how you can artificially, divide your data if you want to do it. And like I mentioned, there are many cases where it really depends upon the business requirement that what kind of ranking business want us to use once we are formulating the output. And obviously, like I mentioned, row number has been used a lot once we build our script from the ranking function. Rank and dense rank used as well sometime once we are producing. And entire rarely used, right? But now you can understand what's the why we use the Windows function and what's the difference between Windows and the pure aggregation function. So in the next video, we're gonna look at the second form of the Windows function, which is obviously Windows-based aggregation, and afterward we will look at the third type, which is obviously, if I remember, let me just go back. Yeah, accumulating aggregates, right? So we'll see in the upcoming video. So I believe you understand the main concept of the Windows function, and you understand through these examples that where we use these function in our day-to-day activities. So please put any comments if you have any question. Otherwise, like the video, and I'm gonna see you in the next episode of the Windows function. Thanks for watching.